Good afternoon, everyone. My name is Sebastian Meyer, and I'm leading Sub-Project 5 within the SILS initiative focusing on radio frequency. Today, I would like to give you a short overview of the results from Phase 2. First question is, why radio frequency? Radio frequency has become an essential part of modern vehicle architectures. It is used across a wide range of applications, for example, in telematics, information, infotainment, especially sensing systems, cameras, radar, ADAS, and for automated driving. The widespread use of radio frequency highlights the need for standardization. However, it was not yet systematically covered within the existing standard. This also meant that this is basically the point where Sub-Project 5 comes in. Our goal was to integrate radio frequency systematically into the existing standard. So next question would be, what is radio frequency in the context of the DIN norm? Radio frequency is defined as an application layer for high data rate transmission using dedicated data cables. Looking at some key characteristics, typically we are dealing with point-to-point connections without any branching. Cables must be shielded cables, such as coaxial cables or multi-core cables with common shielding. What makes radio frequency special are several key characteristics. First, connector systems are quite sensitive, often allowing only a limited number of summating cycles, or sometimes even just one. Second, the shielding is, of course, essential for proper functionality. Therefore, radio frequency integrity depends on continuous shielding across the entire system, from the cable to the connector to the socket, with strict EMC requirements. And the third, cables themselves are mechanically sensitive with limited bending radii, and basically where even small damage can affect performance. Typical systems here include FACRA, HSD, or mini coax. Looking at the current situation, radio frequency manufacturing is already highly automated. Many process steps are performed completely automatically, and at the same time we have a very heterogeneous landscape. So we see a high variety of products, proprietary solutions, and complex company-specific product systems. So as a result, a one-size-fits-all solution approach is not feasible. So this makes standardization a little bit difficult. However, there is still potential. Sorry, so fast. There is still a potential for standardization, even if it's not immediately obvious how to define it. Therefore, the first step was to integrate radio frequency into this existing standard by evaluating existing design rules. So our operational start was in July 24. As I said, the first step was to evaluate the first and existing low voltage rules, if they are applicable. For radio frequency. In total, 88 design rules were reviewed. Out of those, 30 were found to be usable, 17 classified as rules, and 13 as recommendations. This naturally led to the question on how to proceed. So building on this, we identified new topic areas, prioritized them in a workshop, and structured them in a dedicated idea backlog. Looking at the findings and results from Phase 2, as mentioned earlier, radio frequency manufacturing is highly automated at the current situation. This also means that the remaining potential for additional design rules is very limited. The remaining topics are mainly found in more complex areas, such as handling after cable assembly or system integration, like automated installation in the vehicle during production, or the provision of manufacturing-related data, basically Industry 4.0 idea. As a result, we decided to focus on a more practical, implementable topics and postpone the more complex long-term topics. Based on this approach, we already were able to define the first concrete design rules. These include a design rule for minimum cable length to ensure automated processing, and also a design rule which defines the real direction for components in order to improve compatibility with machines. Shown here are the part of the design rules, especially for the real design rule, where we have the images. So basically, what is okay and what's not okay, which direction. The key project information is outlined on the final slide. To summarize, basically, radio frequency has been successfully integrated into the existing structure. Many existing concepts could be transferred, and the need for additional radio frequency specific design rules turned out to be limited. Going forward, the focus will be on manufacturing relevant topics and the further development of prioritized content as discovered by the ideation process. Thank you very much for your attention. That's it for subproject 5.